Hey, welcome back. We are starting Unit 2 today, Lesson 6, Day 1. So what you're going to need today is your materials, is your notebook, lesson book, and a pencil. We're going to be on page 53 and 54. So today we're going to be able to define a relationship as a function. So let's think through this. What is a function? Pause my video and write down in your notebook, what is a function to you? Let's see. There could be several answers. Okay. So, did you say that a function has to do with an input and an output? Maybe a function has an independent and a dependent. Maybe we have an X and a Y. Did you say table, graph? Any of these things that you had from 6th and 7th grade? All the way through, I guess, 4th grade even, y'all talked about functions. They are all correct. Okay, so what is a function? Well, in this case, I have a function in front of you. I have an input of 3 and an output of 5. What do you think is happening between my input and my output? Do you think we're adding 2? Let's see. Oh, well, yes, there we are. 3 plus 2 is 5. So in comes an input, something happens, and then we have an output. It's just like kind of like a machine, So a function, in order for us to have a function, we can only have one output for each input. Okay, there's only one output for each input. So my output is my Y, my input is my X. So let's see what that looks like. Okay, one output for each input. Okay, let's see what that looks like. Remember, we're talking about functions. What is a function? Okay, so we're going to talk about relationships that are functions. I can only have one input or one output for each input. Okay, so again, I want you to pause my relationship, pause my video, and I want you to write down in your notebook some type of relationship in the real world that are functions. Okay, so pause my video and think about some relationships that are functions. Pause. Okay, let's see how you did. There's so many out there, but I do have a few examples here. So for example, money. Here's a penny, a nickel, dime, quarter, okay, and there's my values. So you might not have thought of this as being a functional relationship, but each input and each output, see there? Okay, my inputs aren't repeating because I have an output for each input. That's very important that we know that. I have an output for each input. Now, this to you, you're looking at this and it's not a, if I'm thinking about ordered pairs, well, these ordered pairs are a little different. Each one of these ordered pairs represents a coin. Okay, well, what about this one? You might have recognized one of these. Look at this one. Miles to calories. So each time I run a mile, I burn a certain amount of calories. Each output has one input. Each output has one input. This is functional. And as we're looking at this, can you remember your 6th and 7th grade skills to see if we remember what proportional means? So look at this. We've got 65, right? 1 times 65 is 65. Do we notice that we can multiply this to get that? Okay, so do you remember what proportional means? Yeah, hopefully you can remember that you've got it to where we're multiplying. We're multiplying our input to get our output by the same number every time. Okay, we're going to need this knowledge as we get into Unit 2. Proportional functions, how things are related and rate of change. All those words are coming back. Initial value. So all of that's going to come back. Okay? All right, so what I want you to do now, I want you to give a situation where give a situation that would be a function and it's proportional. So I want you to think about this because we're going to need this knowledge as we dive into Unit 2. Think about a situation that's a function and then ask yourself, is it proportional? Does it move the same every time and there's no initial value? That's proportional, okay? Because like with the miles, if we didn't run, we weren't going to burn any calories. So think about this. So pause my video and answer this question in your notebook. Go. Okay, so I came up with some of my own. And, let's see how you did if you have any like mine. So a Coke machine. If I don't put any money in the Coke machine, I'm not going to get a Coke. But each time I put in $1, I get a Coke. $2, I get 2 Cokes. Okay, that's a proportion and that's a function. I can't put $1 and get 2 Cokes. Well, that's happened before, but that's, that's not normal, right? Okay, but that's the idea I want you to think about, is that it can't be a function if I put $1 and out comes 2 things. Okay, what about distance and running? So, and distance and running would be, I guess, like I was thinking more of like as like time, right? So time and running works. Job with money. Each hour, I earn money. If I don't work, I don't earn. But I can't have 2 hours that I work and get, I can't get paid for the same 2 hours. I have to have one output for each input. Okay. So those of you that came up with some ideas, why don't you ask people around you that are at home with you, to see how yours kind of compare to mine. Because just because you have different ones doesn't mean that yours are wrong. Okay? All right, so now let's talk about what are not functions. Okay? So let's look at this one. We have jersey numbers and we have height. So let's look at these jersey numbers. 10, 13, 14, 18, 21. Okay. And then I've got height, 68, 73, 75, 68, 74. Okay. So I've got 2 heights that are the same. But look at my jersey numbers. Is that okay? So if I'm looking on the basketball court and I'm trying to find the numbers and who plays where, is that okay that I have 2 people that are the same height with different jersey numbers? Oh, that is okay. All right. So is this a function? I have an output for each input. Yes. Okay, so what happens if we flip it? What happens if the height becomes my input and the jersey number is the output? Look what happens. So let's look at our rule again. It's got to have 1 output for each input. So output, input, output, input, output, input, output, input. Do I have 1 output for each input? This case, I have 2 outputs for 1 input. Does that follow our rule? that doesn't follow our rule. So this could not be right, okay? This could not be right. We have to make sure that there's only one output for each input, okay? And which one is that true for? Is it true for this one or this one? That's why, okay? So it's true for this one. That's what makes this a function and this not a function. So what do you notice in order for it to be a function versus not a function? What do you notice? Can my x's repeat? Okay, can my y's repeat? So my y's can repeat, but my x's cannot. So that's what one output for each input means. My x's cannot repeat. Okay, so let's look at that let's try another example with that, okay? All right. So now I want you to try to think of some situations that are not functional. So I want you to pause your video just like we did before. We thought about situations that were functional. Think about ones that are not functional. So you want to give a situation where your x's might repeat, which would not make it functional. So pause my video and write some situations in your notebook. Go. Okay, so there's a lot of situations that are not functional. I just came up with a few of them. You ready? All right, so I came up with, well, there, your shoe size and your hair length. So if I'm sitting in my classroom and I ask my kids to take off their shoes, do you know how many of their shoes are going to be the same? A lot of them, right? And their hair length, but it's the input. It's the input. My output, I need a output for I need each output for each, one output for each input. So my inputs cannot repeat. Shoe sizes can't repeat. Now, what happens if I flipped it? I might very well have no repeating lengths on the hair. But, so I could have several hair lengths and the same shoe size. And that's okay. That is absolutely okay. But if I flipped it, would that be okay? No, I'd have definitely repeating. Okay, what about age and siblings? Now, I'm thinking of my classroom here. So, how many of the same ages do we have? We have a lot of the same ages. I could say your age and the month you were born. Well, I might not have repeating months, but I will definitely have repeating ages. So as you're looking at your situation, is your x's allowed to repeat? And if you know that you've got a huge chance of your ages repeating, you know it's not functional. So let's look at what that looks like when I actually graph it, okay? So here we have grade and the number of books we read. Okay, so I wanted to kind of give you a real life scenario in your head to visualize why, what makes a function a function. So let's go ahead and graph this. So 8th grade, you read 9 books. 7th grade, you read 12 books. And then 8th grade, again, you read 6 books. I want you to look at how this is, okay? Do you see my line going up and down? So if we did the vertical test and we're on the same line like this, it's not a function. My x's repeat. And so if you needed a mental visual picture ask yourself this. Could I have read 12 books in 7th grade? Absolutely. Could I have read 9 books in 8th grade? Absolutely. Could I have also read 6 books in 8th grade? I either read 9 or I read 6 or I read 15. But if I visually think about, I read 9 or I read 6. So if I need to think about it that way, I just kind of wanted, that's how I see it, is that I can't have it, you can't have your vertical line test to be the same. So I couldn't have read 9 books and 6 books. It's either 9 or 6. And so this gives you a visual. Now, if I flipped it, would it be a function? So if I flipped it, so this is what it looks like if this is my x and this is my y. So if I flipped them, so you have 9 to 8, 7 to, wait, I'm still looking. Okay, let me flip it in my head. So 9, there, oh, okay, 9 to 8. I'm also going to have 6 to 8 and 7 to 12. Okay, look at how different this looks. This is the difference between a function and a non-function. Okay, our other one was this way. Okay, and we had this happening. A function moves. Okay, time goes like this, it never stops. So I always imagine that when I have one on top of the other, that I'm in the same place. I'm in 2 places at one time, because I think of my x as being a continuous line that never stops. And in order to have 2 of the same, I would have to be in 2 places at once. And that's not possible. That's why it's not a function. But if I flip-flopped them, this would be functional. Our function doesn't have to have a relationship between each other. I just cannot have 2 inputs that are the same, because that would mean 2 outputs make 1 input, and that's not a function. So let's reflect. Pause my video and answer this question. Do the data in this table show a function? If you switch the input and the output values, is it a function? Explain. So pause my video, write this in your workbook, and then we'll go over it. And go. Okay, let's see how you did. Does the data show a function? So I have input has an output out. Well, wait a minute. These 2 are 3s, aren't they? So I have an output and 2 outputs with 1 input. Well, wait a minute. That happens again, doesn't it? So is this a function? This is not a function. My x's repeat with my x's repeat. Or you could say that I have 2 outputs for 1 input, another 2 outputs for 1 input. So the next question says, if I switch it, so let's switch it. So I'm going to write my outputs down here. So this is my input, and here's my output. Do I have, let's see, different, yeah. And this would work. It would work because I have an output for each input. All right, good job, guys. Welcome to Unit 2, Day 1. So I'll see you next time for Lesson 6, Day 2. Bye.